This will be the last integral problem you see in this room. And I only made that for the year 2024 because in 2025, we're back with new content. But of course, don't forget that if TikTok does get banned, I'm gonna start posting a lot of my content on Instagram and YouTube, so make sure you follow me on there. Okay, so here we have the integral from 0 to infinity of e to the negative 2x sine of 3x all over x with respect to x. So we're gonna go ahead and solve this using the Feynman technique. So remember, the Feynman technique makes us create a function in respect to alpha. I like alpha. Some people use t, some people use other variables, but I personally prefer alpha. And you create an integral where your alpha goes somewhere in here. Typically it replaces one of the constants. You can probably replace the 3, but I'm going to replace the 2 there. So this is going to be e to the negative alpha x sine of 3x over x with respect to x. Okay, and before we do this, before we even start taking the partial derivative with respect to alpha, we need to find some condition. If we have I to the infinity, then we're gonna have integral from 0 to infinity of e to the, now we're gonna make that infinity, so we have negative infinity x sine of 3x over x. Check out what's gonna happen here. Because that's a negative infinity, it's gonna go on the bottom. So you're gonna have infinity in your denominator, which is gonna send this whole thing to 0. So now we have this condition that I to infinity is equal to 0. We're definitely gonna revisit this later on. Okay, so now we're gonna go ahead and take our partial derivative with respect to alpha. On the left side, we just get I prime of alpha equals, and then over here, all you have to do, since we're taking the partial derivative with respect to alpha, is treat every x variable as a constant, because we're not differentiating with respect to x. We're only worried about the alpha. So we're really just gonna take the derivative of this and then multiply this entire thing. When you take the derivative of this with respect to alpha, you're gonna get 0 to infinity of negative x e to the negative alpha x sine of 3x over x dx. Definitely practice with that, because again, a is the variable, x is the constant. So if this was like 2x, 2x, and it will be, or 2 alpha, I guess you can say, then the derivative will be negative 2 on this case. Okay, so the reason why we did this is so that these x's can cancel out, so this negative can go on the outside. So we have I prime of alpha, negative 0 to infinity of e to the negative alpha x sine of 3x dx. Okay, so this is where we're gonna go ahead and bring our Euler formula to talk about that sine 3x. Okay, so here is our Euler formula where theta is the argument. So now we're gonna change that theta into negative 3x. So we plug in negative 3x for every argument for the cosines and sines. Cosine is even, so that just becomes cosine 3x. Sine is odd, so that negative can come on the outside, and now we have negative I sine 3x. So, because this is basically what we wanna worry about, because that's exactly what's in here, we just want the imaginary part of e to the negative 3ix, and that's gonna be negative I sine, whoops, not the imaginary part, I mean, it's just gonna be sine, negative sine of 3x. Because I'm calling for the imaginary part, I'm just getting the imaginary portion, so I don't need to put the I there. So that's exactly what we're gonna do in here. We're gonna go ahead and introduce this, and remember, we only want the imaginary part. So what we have is our I prime of alpha is equal to the imaginary portion of negative 0 to infinity of e to the negative alpha x, and then we have e to the negative 3ix. I had to put my dx in here, and then remember, this imaginary part had a negative sign on there, so this negative sign could cancel out with the negative sign that was in here for the imaginary part. All right, let's continue. Let's go ahead and combine these things so that we can go ahead and integrate. So we have the imaginary part of this integral from 0 to infinity. All we have to do is just add the exponents, but instead of that, I'm gonna go ahead and factor out an x, because that's what they have in common, or a negative x, if you will. And this is gonna be alpha plus 3i. And then we have dx. And again, if you were to distribute the negative x, you will notice that it's the same value. Okay, now we can go ahead and integrate with respect to x. All we're doing is a u substitution. And if you do that on your own, or on a separate sheet of paper, if you will, you're gonna have e to the negative x alpha plus 3i all over negative alpha plus 3i, and then from 0 to infinity. I know people get really worried about the infinity. I should put a b and then take a limit, and that's totally true. But you know, we're just way past that at this point, just for the sake of integrating these things. Okay, so when I plug in infinity in here, I'm gonna get e to the negative infinity. Now remember, just like in the very beginning, when you had a negative infinity, it goes to your denominator, so it becomes 0. So we know that part is gonna be 0. So we have imaginary portion of 0 minus, and then now we're gonna go ahead and plug in 0 in here. E to the power of 0 times anything is just 1. So we have 1 over negative of this right here. Now, because you have a negative part on there, I'm just going to put a plus 1 over alpha plus 3i. Okay, so this is our answer right here. But again, we really only care about the imaginary part, so we want to find the real and the imaginary portion of this expression here and only pull out the imaginary part of that. And what better way of doing that than taking the conjugate? So we're going to multiply both the top and the bottom by alpha minus 3i. So we have imaginary of, this is going to be alpha minus 3i over, and then this is going to be alpha squared plus 9. And if we split it up, we have alpha over alpha squared plus 9. And let's just go ahead. So we have alpha over alpha squared plus 9 minus 3 over alpha squared plus 9, and then we have the I. So we really just want the imaginary portion, which is this one right here. We just want negative 3 over alpha squared plus 9. Okay, so here we are. We still have the I prime of alpha, and we want the imaginary portion of this expression. This is the real part. This right here is the imaginary part, so we're just going to go ahead and use this one. So we have alpha prime, or I prime alpha, is equal to negative 3 over alpha squared plus 9. And now we can go ahead and start integrating with respect to alpha. This is the Feynman technique where we now integrate back so that we can find our original I alpha. This is just going to be I alpha equals, and then this is just a simple arctan problem. This is negative 3 over our A value, which is going to be 3 arctan. For those people watching, I'm changing it to arctan to appease those people. And then of alpha 3 plus our cheese. All right, so let's talk about this. Because we still have the plus c, now we're gonna go ahead and use this condition right here, that when alpha was equal to infinity, that's exactly what I should have put on there. I'm so sorry. If you are seeing this from the future, you know I changed it. Anyway, so we have I of infinity. So what happens when you plug in infinity here? I of infinity is equal to negative arctan of infinity over 3 plus our cheese. We know that this was going to equal to 0 since we have that here, 0. And then arctan of infinity is just pi over 2. So we have negative pi over 2 plus our cheese. And we know that now pi over 2 is equal to our cheese. So our original integral, I alpha, is equal to negative arctan of alpha over 3 plus pi over 2. Well, all we need to do now is reference this back to our original problem where alpha was just a placeholder. We want that to be 2. So let's go ahead and plug in 2, and we are going to get our official answer to this integral, 2 over 3 plus our pi over 2, and we are officially done integrating this using the Feynman technique. Pretty sick. All right, you nerds, I'm gonna go ahead and start taking a break. I'm gonna visit some family. I'm gonna visit friends. I'm definitely gonna start reading more math books and just ready to improve our math content for 2025. So whatever you wanna see or whatever goals you want for 2025, let me know in the comments and I'll see you soon.